All right. Hi, grade nines. It's been a little while since we've had a lesson. That's just because we had our test, right? And then we had a couple days off where we had a long weekend, and then just didn't make sense to start a new unit until now. So here we are, we're back. Our next unit that we're going to be working on is linear relations. So let me see, I gotta share the right screen with you. Now, I understand that a lot of us aren't necessarily going to have access to printers or be able to print off those booklets, and that's totally fine. So what I've decided to do is rather than have you all kind of have different setups, which you can still do, you can use Cami if you want, you can use, you can print it off if you want to, or you can use loose leaf. It's up to you. But what I'm going to do is the way that I think it's most accessible to everyone is rather than using this booklet myself personally, what I'm going to do is I'm going to do all of my lessons on loose leaf. And what that results in is you being able to either follow along with my loose leaf lessons on your booklet. It should still work out the same. Or if you don't have a booklet, you can follow along with this. So this is going to be the way that we're going to do things from now on, just because of this at-home learning and everything. So just make sure that you have some loose leaf that you can work on and follow along with what I'm doing. And I'll be writing out everything that you need on here. So we won't be able to maybe get through as many examples because I'll have to write the examples out, but that's okay. But I do think that it will be more useful for all of us. Now, there will be a few alterations to the lessons. So I do want you to just either find some space inside of your booklets, if you do have the booklet, to be able to write the stuff out that I am writing out. What you'll notice here is in my booklet, I actually, for some reason, page 1 didn't print off. And then I looked at example number 1, and I kind of wanted to just start off a little bit easier than example number 1. So if you want to do example number 1 from the booklet, as well as example number 3, I'm going to do a different example number 1, and then I'm going to do the plain example that you saw there. So I'm going to do 2 examples. We'll do a little bit of a refresher to start off, and then I'll give you some textbook questions that you can work on tomorrow. So anyways, enough about all of that. Let's get started. So today we're learning about linear relations. Okay. Now, we have learned about what an expression is, and we've learned about what an equation is. Let's talk about the difference between that. So again, kind of confusing. It's our unit 5.1. It's the textbook's unit 4.1. Okay. And in the textbook, it is pages 154 to 162. Okay, so that's all really useful stuff for you there. All right, let's do a little bit of a recall here. So let's recall some things. Recall. What is the difference between an expression and, let's do that. What's the difference between an expression and an equation? Try to think if you can think of, before I've even got started here, try to think if you can think of what the difference is between an expression and an equation. An expression is a number or a variable or some sort of combination of those. But the key with an expression is that there is no equal sign. No equal sign. Okay, so our example, let's get a different color here. Let's use yellow here. Our examples of expressions could be 3n, could be 4p plus 1, could be 6x minus 2, could be 129. Okay, but you'll notice that all of those don't have equal signs in them. It's because they're expressions, they're not equations. Now, let's take a look at what an equation is. Technically, I've got a very technical definition here. It's a mathematical statement. A mathematical statement with numbers, variables, or a combination that has an equals sign. So my example for this, again, you could just kind of use your imagination for examples, or could be 3n equals 6. Could be 4p plus 1 equals 17. Could be 6x minus 2 equals 129. Okay? So there's our difference between an expression and an equation. So now that we've done that little review, we recalled that from maybe our previous math courses, let's do example number 1. Now, like I said, example number 1 is going to be different than the one that is in your notebook. I'm trying to figure out the best way I want to write this. Example number 1. Okay, so a landscaper used wood boards to, oh, sorry, not to, as, my bad, as edging plots, call them edging plots, in a garden. And this is what they looked like. So there's either one plot, which would look like this, or it could have been 2 plots, which could look like this. Or it was 3 plots, which could look like this. Right? So this could be our 3 plots. And then et cetera, et cetera, et cetera. Okay. So let's let a couple things be the case here to help us out. First off, let's let the number of plots, let's call it P, and then the number of boards, we'll call it B. That's important. Now, here's our actual goal. Our actual goal, we have 3 of them. A, make a table of values relating P to B. Make a table of values relating P to B. Okay, and then write an equation relating P to B. And then part C, how many boards are needed for 20 plots? So it's a more specific question. How many boards are needed for 20 plots. Okay, so there's our questions. So let's get started. Part A, let's make the table. Make the table, we can make it over to the right here. A. We'll do number of plots, so that'll be P. And we'll have the number of boards, which will be B. And we will separate them like that with maybe the least straight line of all time. And there we go. And we will say that the relationship between the number of boards and plots. So let's take a look at the first one. One plot. One plot. How many boards did one plot require? It needed 1, 2, 3, 4. So one plot needed 4 boards. Okay. Now the next plot, I went from 1 plot to 2 plots. And then I went from 2 plots to 3 plots. So our relationship or our pattern that we're seeing here is every time this one is increasing by 1. Right? Every time I go to the next one, it's increasing by 1. So we can just extrapolate that and keep going. This one's going to increase by 1 and increase by 1. Let's do up to 5. Now, what happened with my number of boards every time? So I had 4 boards initially, and then for this next one, let's count out the boards. 1, 2, 3, 4, 5, 6, 7. Okay, write that down. Maybe we're not quite yet. Let's do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we're basically seeing is every time I'm adding 1, 2, 3. I'm adding 1, 2, 3. So I'm always adding, so as it becomes 10, I'm always adding on this side, we're always adding 3. So again, just extrapolate it out. This is going to be plus 3, this is going to be plus 3, and now we've got a serious pattern going on here. 10, 13, 16. So there's our table. That's a fantastic table. That's a great table. I mean, I would have rather, if I did it again, I would have moved these in, but that's okay. It works, totally works. So there's our table. What else? Another thing that we could do is maybe just make some lines separating these. There we go. Not the prettiest table, but it works just fine. Okay, let's take a look at B. Part B. Write an equation relating P to B. How do we do that? How do we know how to relate P to B? We need to kind of basically look at the connection between these two right here. If I have 1P, how do I get to 4B? And if I have 2P, how do I get to 7B? Basically, what we have is if I have 3 plots, plus 1 will give me the number of boards that I need. So I'll show you. The equation here is 3 times 1 plus 1 will give me 4. 3 times 2 plus 1 will give me 7. 3 times 3 plus 1 will give me 10. So my relationship between the two is 3P plus 1 equals B. Okay, now that just comes from a little bit of experience and knowing how to recognize a problem like this. Basically, we're just going to have to continue to practice this until we get better at it. So in most cases, I'll give you a little bit more hints in terms of how to come up with the problems or the equations on your own. But in this case, basically what I saw is that for every time this increases by 1, this has to increase by 3. So for my P to increase by 1 every time, I have to increase my B value by 3. So that's how that works. So let's move on. Part C. How many boards are needed for 20 plots? Well, we know that we need 20 plots, so P is equal to 20. What is B equal to? Plug it into our equation. 3 times 20 plus 1 equals B. So 3 times 20 is 60 plus 1 equals 61. So we need 61 boards for 20 plots. Okay. Let's move on. So an airplane is flying at 10,000 meters. This is the one that's actually in your booklet. An airplane is flying at 10,000 meters. It begins to descend, and the following table that we have on there shows its descent. So we need to write an equation which relates the height to the time. We need to know what the plane's height is after 20 minutes. We need to know how long does it take for the plane to land. Sorry, just give me 1 second here. I'm just trying to think if I want to actually write this out again on here or if I want to do it on the actual page. Let's just write it out here. And if I write it out here, I think you might be able to get a better idea of where I got that expression from for the last question. So, example 2. An airplane is flying at 10,000 meters, begins to descend, begins to descend. The following table shows descent. Shows its descent. So I'll just write out the table here. You've got the time t in minutes, and you've got the height h in meters. All right, and then our values on the table go like this. 0 minutes to 1 minute to 2 minutes to 3 minutes to 4 minutes. And our height goes from 10,000 to 9,700 to 9,400 to 9,100 to 8,800. So our goal here is to kind of see a pattern in these numbers first. That's our first goal. And what I'm seeing is that every time, hold on, let's just do this. Make this into a nice full table. What I'm seeing is that every time I go down here, I go +1, +1, +1, +1, right? And this time what's happening is we are decreasing by 300 every time. -300, -300, -300, and -300. We do have a relationship between these two numbers. Every time this one increases by 1, this one decreases by 300. So our questions are A, write an expression or an equation relating the height to the time. So write an equation relating h to t. And then what is the plane's height? What is h? What is the plane's height? So what is h after 20 minutes? Or you could say at 20 minutes. No, after. We should definitely say after. After 20 minutes. And then C, how long does it take the plane to land? That one's kind of tricky. Take to land. Okay, so for part A, I just want to go back and look at the relationship that we found out here. So what we saw here was that for every increase of 3 boards, we had an increase of 1 plot. And in this case, for every increase of 1 minute, we have a decrease of 300 meters. So if I set it up again in the same way, what we're going to do, like we did here, I started off with 1. Okay, I started off with what my base is, because if my P ends up being 0, then my base is just 1. Okay, so if my P here is 1, then that's going to make my base 4. So that's always the kind of the goal. So here's the relationship. You start with your base number that your plots could be. So my base number that my height could be is 10,000. Let's do this in a different color. Because, yeah, so 10,000. And then what I said was, I'm relating B to P, right? So 10,000 is my base number, my base height. And I have to find out the relationship to find H. So what changes every single time? Well, here what changed every time was I added a +3 times the other variable, which was P. So in this case, I'm figuring out what my relationship is here. It's -300 times my other variable, which is T. So that's how you always set these up. You set up your base amount and then how much it changes by for every 1 that you increase here. So 10,000 minus 300 times 0 is just 10,000. 9,700 minus 300 times 1, well, 300 times 1 is just 300. So 10,000 minus 300 is 9,700. And then times 2, that's 10,000 minus 600. Times 3, that's 10,000 minus 900, which is 9,100. So like I said, we get better at this the more that we end up doing it. We follow that kind of rough formula. Basically, what you need to do is just make sure that you're looking at what 2 initial values you have and then how they relate in that next step. So you're finding that -300 that it jumps to, and that's what you're working off of. So, like I said, you will get better at this as we start to see them more often. And it's also can just be a little bit of a trial and error type thing. If you don't get it right away, try a couple different ones until it makes sense. So, what is the plane's height after 20 minutes? So if t is equal to 20, what is our plane's height going to be? So all we have to do is just plug it into this formula. So 10,000 minus 300 times 20 is equal to h. So 10,000 minus 300 times 20 is 6,000. So 10,000 minus 6,000 is going to be equal to our h. 10,000 minus 6,000 is 4,000. So our h is equal to 4,000. So height is 4,000 meters after 20 minutes. So it's not descending very fast at all, but that's okay. All right, let's go with C now. C, how long does it take to land? This is kind of a tricky one here, but one thing that you need to remember is when it lands, what is its height equal to? When it lands, it's on the ground. H is equal to 0, right? So then all that's left to do is find time. How long does it take, right? In this case, we're trying to find what the height was equal to. In this case, we're trying to find what the time is equal to. So we have 10,000 minus 300t is equal to 0. Now comes the tricky part. I need to do a little bit of rearranging of this equation. So we need to remember how to rearrange an equation. I have equals 0 on this side. I want to move my 300t to the other side. So I'm going to do plus 300t on this side, and I'm going to do plus 300t on this side. And what that's going to end up doing is it's going to cancel these two out. And what I end up with is 10,000 equals 300t. Now I need to solve for t. What do you think I do next? If here, in order to move the 300t to the other side, I had to do the opposite of subtract, I had to add, what's the opposite of multiplication? Division. I have to divide by 300t on both sides. And if I do that, these will cancel, and I will end up with 10,000 over 300 equals t. That's how you solve for that. If I get that, I do 10,000 divided by 300, I should get t equals 33.333 repeating minutes. So our final answer here can be plane will land after 33.3 minutes. Let's just write it out. Okay, so that will be all that you need to do for today. For tomorrow, what I want you to do is work on some textbook problems. So the textbook problems that I want you to work on are on page 159, and they are numbers 4 through 9, 11 to 16, and then if you can, I want you to try 19 to 21 as well. I know that seems like a lot, but you have some time. You have quite a bit of time to work on it. And again, this is one of those types of things where I just want you to do as much as you can, okay? Don't stretch yourself too thin. Don't bite off more than you can chew, as they say. Just do as much as you can. Whatever you get done will be awesome, okay? So thank you for following along with that. I will post an update for you tomorrow on what we can what we can move on to from here, okay? And maybe a little bit more clarifications if you need on how to come up with maybe some more examples of how to come up with the all-important first equation. Okay, so have a great rest of your day, and I will talk to you tomorrow.